Okay, let's go. Let's go. Get it? Go. We're writing go. Yeah. Uh, Here we have Visual Studio Code. We will be using this editor, and let's open the terminal as well. That there, and then we will go to our source directory. So, what are we going to program, create? I hinted at that in the last episode. I said that there was going to be something awesome, but it's not going to be something very awesome. I will try to implement Conway's Game of Life, and there are a few reasons for this. First of all, it's listed on many pages as a good starting project, and that's one reason. And if you're the least interested in programming and hacking, this is a good piece of trivia that you should be familiar with, in my humble opinion. But those aren't the main reasons. The main reason is that there are really clear rules, and also we have some really clear test cases here. I will try to do this in a test-driven manner, but we'll just see how it turns out. So there are our specification, if you would like to call it that. Also, I have here, I'll try to remember to put these up in the description. This is a good blog. This is not the one I was thinking of. There is a better blog post. It's probably down here. Effective Go. That is a really nice. Yeah, a lot of stuff is explained here, and I found this at. It started as a talk by Rob Pike, and there's a link to the video here. It's sort of yeah, it says it up here. Simple, poetic, sort of sayings about Go and programming in general. So I will keep this here just to remind myself if I get stuck. So, where to begin? We should probably begin somewhere here. And no, let's begin here. Creating a folder for this project, and we will call it Conway. And in here, let's open it here now. Open folder. And okay. We will create. I might, as we go, I might just realize that I've done things in a bad way and just rearrange stuff, but that's part of learning, so just bear with me. I intend to implement this as sort of a library, and then I will at a later stage we will use the standard library tools for making a command line interface for it. And I think I will try to make a web front end in some way also. Just some yeah, we'll see how it goes. Let's start by making a let's do it like that, and then we will have a Conway underscore test.go. I do believe that the standard library test package looks for files that end with underscore test.go. Let's look it up. There was something about testing in this here. Blah, blah, blah. File name ending with underscore test.go. That contains functions named test blah blah blah. Okay. One thing I like about Go that I also like about Python is the super awesome standard library. There are so much stuff built in. So, should it be package main? I suppose so. No, it's the package name of the. So I suppose this should be called package Conway then. I think if we import this file and that contains the meat of the whatever the business logic, when we import this into, maybe we create another project that wants to import this, and then I think we use the full path. In this case we write import github.com/nllptr/conway. I think that's the full path to the package. But in the source files, it's just the, I think it's called the base name. It's just sort of the last part. Okay. Import testing. And then let's take a look at the wiki page to check out the rules. Okay, so basically we can take a look at these down here. The game is essentially a grid with cells that are either alive or dead. If a cell on the grid is alive, it has a black dot in it, and depending on how many neighbors that cell has, in the next generation of the grid, the cell will either continue living or die, or if it's dead, it might even spawn or become alive. So these are some common patterns. A block of 4 alive cells just keep on living, they don't change. There's something called a blinker. This glider is a common symbol in the hacker world. You might come upon it sometime. Okay, so here are the rules. Any live cell with fewer than 2 live neighbors dies. So if you look at this cell here, when it's in the vertical position, it only has 1 neighbor below it, so it dies in the next generation. And if you look at this block, each alive cell has 3 neighbors, which is more than, they only die if they have fewer than 2. It does not have fewer than 2 live neighbors. So it's not starved or underpopulated. Any live cell with 2 or 3 live neighbors lives on to the next generation. So any alive cell in this block, they all have 3 alive neighbors, which is why they just keep on living. Any live cell with more than 3 live neighbors dies as if by overpopulation. And any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. We can take a look at this blinker again. Down here. Let's take a look at this cell. When it's dead, it has actually these 3 neighbors, which is why in the next generation it becomes alive. And the same is true for this cell. So my first hunch is that we will need some kind of function to count neighbors. Neighbors of and this function would probably take as parameters the world or the grid and the position that we are looking at. So there is we have some definitions to make. This world thing, grid, could be represented by some sort of 2-dimensional array, but in Go I have heard that when you use when people ask, I've seen people asking questions, why can't I use this array, and they often get the answer that they should not be using arrays, they should be using something called slices, which is basically an array with a thin wrapper around it. That basically arrays in Go, they have a fixed size. Slices, on the other hand, if I try to append to a slice and it's too small, it will allocate a new array with enough space. Anyway, we need to define some kind of world grid thing. How do we do this? I think, isn't it type def? No? Let's call it world. Maybe it's just type world, which is a slice of booleans, perhaps. if it's true, it's alive. If it's false, it's dead. Let's try that. It compiles without errors, I think. And we also need a function. Okay. Test. Okay, well, let's do it like this. Test create new world. That could be one function to create a new world and initialize it. And what was it? Testing something? Some stars and pointers stuff magic. T, which is a pointer to a testing.t. T star testing.t. Let's just call it new. Test new. Oh, maybe declaration. What's that about? Oh, it's a function. Duh. Is that all? Yeah. Okay, so this is a nice way of structuring your tests. You first you declare a struct, define a struct, and then the different test cases, and then down here we use the range. It's a built-in that returns, that iterates over these cases, and then we can execute or test against these values. So let's try that. Let's call it cases, yeah. This might be unfamiliar with you. It's sort of, it's not dynamic, but it simulates dynamic typing in that you don't have to specify a type for cases. The cases variable, it will just it will figure it out on its own. This is a struct, and it should look like, okay, so in parameters for new should be dimensions for how big this world should be. In maybe x in, and y in, and those are ints. That's probably okay. And this is we'll see if this is okay by the compiler. You can specify, you don't have to, we can do it like this, or maybe not. Expected bong, found bong, comma, don't you want comma? What's that about? Expected expression. Or maybe it's expecting an initialization here as well. Let's just type something here. 1 1. I think these initializations, I think they want a comma even on the last one. That looks sort of odd, but you just need to accept that. What's that about? Why do you want semicolon? Slice struct literal golang. If you haven't gone through this tour of Go, I highly recommend it. It's really nice. Okay. Could it be that it wants... No, I don't know. What's that about? Maybe it just wants it on the same line. Cannot use one type int as type. Oh, okay. In this, within these curly braces, I need to specify each element of the struct. I was trying to specify the elements of a single struct, so we probably need more curly braces. Yeah. So this within these we type, for example, 1 1 1 2 1 1 and end with a comma, and then cases declared and not used, but that's okay for now. We need some more in our cases struct. We need so these are the x and y are in parameters for our new world function. We also need, I think maybe I figured out what I did wrong earlier. Y int. Yeah, you see I tried to put comma there, but when specifying when declaring the struct, you don't separate the rows by comma. However, we can put these on the same line since they are of the same type. I think that is the Go way to do stuff. We need an expected output, and that is of type world. Want is a world, and do we need anything else? They just have the input and the expected output, so let's stick with that for now. So if we oh, maybe this is a bad test. We probably should populate these expected outputs. We need to populate them somehow, maybe. Never mind. Can we do it like this? World. Maybe we could. Maybe we can do it like this. World. If it's a 1 by 1, it just contains Is it like that? True. I think it's like that. Oh, it should probably be false, initialize to false. I think that we can create another one, a 2 by 2. Maybe it becomes clearer then. World. So here we have a 2 by 2 world, 2 rows and 2 columns. So here is, we first specify the rows in here. Here is the contents of the first row, and here's the contents of the second row. And this first row should contain 2 elements, one false and another false. They should initialize to false. Maybe this is totally necessary. I have to look up if booleans are initialized to false by default. It could be false, false. So that should be our 2 by 2 world. Now I will have to look something up. Go lang make slice. There is a keyword make that it could be that it initializes everything to its null value. Here we make a slice of strings of length 3, initially 0 valued, and a 0 valued boolean should be false. Go lang 0 values. False for the boolean type. Okay, so we could probably use that. Then maybe we can maybe we should just keep this literal. I don't know. Let's keep this like this, and just to sort of cement the concept of writing these this way of specifying test cases. And we will try the make keyword in our new world function. So func new. We could probably finish writing the test. For see range cases. Okay, so this range, built-in range thing takes, I think you can do it on slices and other list / array type stuff. The first parameter is the first return value. You see, functions in Go can return multiple values. So the first return value from range is an index, and the second return value is the individual elements. What are you complaining about now? Declare not used. Okay. You will see in a moment why I used the underscore. Okay, so we just copy their got, and then we use our new function, which we have not written yet, and then we take the test case x and the y values. Those are in parameters for the new function. So now got should contain our new world, and if got is not equal to c.want, we could let's do it like that instead. If got does not equal 1, if we end up here, we have failed the test. T.error. What's the difference between error and Golang pkg? Here you get the standard library things. Testing. We are looking at testing, and the overview, where do you have it? Testing type T, error. Okay, so error just is equivalent to log followed by fail. It logs the error, I suppose. If you are familiar with C and program languages like it, the printf function, you have a format string, and then you this is something like it, and that's the way they do it here. Let's just do it as simple as possible. We just use the regular function, but I want to see an example. I want to see someone doing it. That sounds weird. Reverse blah 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 blah. Okay, let's do the error version. Down new, and then we have our in parameters, which are digits, equals q. What's that? Now we have to look up the pkg golang. I never remember the format. A single quoted character literal safely escaped with Go syntax. I don't really know what that means. Oh, it was this one, double quote, safely escaped with Go syntax. Okay, it's probably they handle escape characters, I suppose, in some fashion. Maybe we should use that one. Let's try it. But here I want to have a new line, and then I want to print. Now how do I print struct? The value in a default format when printing structs. Maybe we should use that one. V. Present V. Wanted, and then new line, and then another struct, and here we, maybe it's not a struct at all, maybe it should be slice, string slice. Let's just try it. The first %q is the in parameter, so that's c.x. Then we have c.y, and then we have got, and then we have c.want. So these special characters are mapped in order to the things I provide after the format string. So this first %q is this one, then the next is the next one, and so on. It complains because we still do not have a new function. Okay, x, we could write it like this: x int, y int. But since they are of the same type, we can do it like that. And now anything with any functions and types we declare that start with a capital letter is exported. Or if you have written Java, it's the same as it being public. So other people importing this package are able to use these functions and types. And since we plan on using this possibly in a super flashy command line interface we want to be able to import this. So I choose to export these types and functions. And anything that is exported needs a comment. It's not enforced. You see, as you see here, I can still compile it, but I don't know what tool it is that complains, but for the sake of documenting the code, we need a doc string, I think it's called. World represents a game of life. Game grid. Okay, so that's okay. And now I will try to screw things up. This is a function. That's not okay. Comment on exported function new should be of the form new blah 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 blah. This is something that I also like in the same way that I like Python. There are a lot of what should I call it? A lot of do's and don'ts, like the Python PEP 8 specification that declares how you should write code, and Go is similar in that way, that the GoFMT tool that formats the code in a certain way, and all these tools that make sure that you write readable code. It might not be your best your favorite format, but at least there is a specified format, and I think that's a good thing. So we should begin it with new. Create this a new world. Okay. Return nil. Oh, we haven't specified a return value for this function. It returns a world. Now we should be able to run this. The first test case. Go test dot. It failed. No. Invalid operation. Got blah, blah. Slice can only be compared to nil. Okay, I expected the test to fail, but maybe not here. Slice can only be compared to nil. Maybe, oh. Maybe we have to iterate over each. Maybe this is not a good way of comparing slices. Golang comparing slices. Checking the equality. Okay. You need to loop over each of the elements in the sliced and test. Equality for slices is not defined. However, there is a bytes.equal function if you are comparing values of type byte. Okay. So we have to iterate over each of the elements. And this is actually, I thought I was not allowed to, you see, since I'm not actually using this this index variable, and if I'm not using it, I should just put a slice can only be compared. Okay. So let's change this. If for I we can use the index only here, and we can just leave out the rest. Range got or maybe that should be a row for that is, let's do it like that. For y column range row. If if the column we're looking at in the row we're looking at is not equal to c.want x y. This could work if we are lucky. Oh, come up. So that was okay. I did not expect that to be okay. Oh, okay, I know why. Because since we return nil, we probably just skip this altogether. So we cannot return. Let's just return some. Can we just do it like that? Should we return? I'm not sure. I'm actually not sure. World. Can we do it like that? Seems to be okay. Is it okay? Ah. should just thumb print some ugly debugging. Oh my god. Hey! I should at least get go test. Okay, maybe it just didn't pick up the test file. That's weird. Maybe we should just type go test. Okay. Now we're on track again. We get 1 hey per test case. Let's try some more. Got. That looks like the what we return from here. 2-dimensional slice. That's actually our first test case. This one. Row. Okay, so there's one of these for let's try printing the col. So this is what we got from the first test, and this is what we got from the second test. It should pass on the first test because the test case here is this kind of world is the same that we return here, but the second test should fail. But maybe we need to check the size also. Maybe it just checks the first column. That's probably what we need to do. Okay, so we could look at the length. That's probably what we should do first. After here, if len, is it like that? Maybe like that. Len, yeah. If length got is not equal to now we could look at c.x. If these are not equal, then we have an error. World size error got x x number of rows do not match got q want q, and q first q is got len got, second q is c dot x. And then when we are in here, if len row is not equal to c dot y, t dot error number of cols do not match got q want q len col c dot y. Now what? Undefined col. Oh. Okay, now we check for size first, and if actually maybe we should do this. If len got is greater than 0, if we have any rows, that's such an edge case, maybe we should just let it explode if we give it bad test values. Row, let's just check the first row. Got donk. Go test. Okay, that's not what we want. Maybe we should not use q. Maybe we should use the d's instead. Number of rows do not match. Okay, so here we fail the second test. This one we can remove now. Okay, we should change these as well to D for digits. Maybe we should try copying this case. What am I doing? And return one with true instead. Okay, so here we failed the first test case. Maybe should actually use this one or not. No, just kidding. Okay, so here we see that new 1 gave us this one, but we actually want but we wanted this. This is sort of backwards. This is what we expect, so if we do it like this instead, here we get something. We get true back from the new function, but we wanted false. So now we just have to work on getting this to return what it should, and I think we can do that by Golang making multi-dimensional slices. Multipass Corpendalas. Slices can be composed into multi-dimensional data structures. The length of the inner slices can vary, unlike with multi-dimensional arrays. Okay, so yeah, I suppose we first make a world is world bonk make a new world with X number of rows, and then maybe not world declared in okay, then we iterate over each of the rows and put a new and put a boolean slice in there with the proper amount of columns. For row equals range world, do I need to maybe not row, let's just try it like this. Make a boolean slice of with y number of elements or columns in our case. Now what is this? Row declared and not used, but I am using it. And then down here we should return our world. Now what's this about? Row declared and not used. It is used. Let's try it like this. We use the index instead, and then world I equals, that seems to work. Let's just row that is very strange. Let's try it like that then. It passed. Woohoo! Maybe we should try a three-dimensional one as well, just because. Or maybe some odd, maybe not with different values. So we have 3 rows. This is the first row. False, false. False, false, and our final row. And comma. That passed as well. Okay, this is probably a very long video, but we got some practice with a few important things. The testing stuff. We will use this a lot, I suppose, in the upcoming videos. So it's a good practice to get the hang of it. And we actually created our world. Okay, so I will stop here and upload this crap, and we will continue some other day. See ya!